Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. In this video, let me introduce myself. My name is Zidan Ulul Albab. I am student at the Malang State Polytechnic, majoring in Electrical Engineering, Electrical Systems Study Program. I will explain about renewable energy, namely solar energy and water, especially in rainwater. Why did I take this? Because lately it often rains in several places in Indonesia, especially in Malang. I was thinking what if we could make use of it, especially if before the rain there is often a sourcing sun. Just imagine the sun rays in Indonesia are very much and spread all over. According to the Ministry of Energy and Mineral Resources, Indonesia has a daily irradiation capacity of 3.8 until 5.0 kilowatt hour per meter square. According to the Ministry of Energy and Mineral Resources, Indonesia has great potential in new and renewable energy. For the renewable energy sector, Indonesia has a capital of 4.80 kilowatt hour per meter square per day. Likewise, with the rainfall in Indonesia, according to the Meteorology, Climatology, and Geophysics Agency, reports that the rainfall in Indonesia has recently been above normal, which is 69.45%. With that much rainfall, if it is used as a source of electricity, it will help even if it is small. Currently, the development of solar power plants continues to be improved. Utilization of the resources that I have described can use a power plant that combines sunlight with rainwater. The utilization can be done in several ways by adding several components in a solar power plant. What is solar power plant? Solar power generation is the conversion of energy from sunlight or solar into electrical energy by using solar panels, either directly or indirectly, or a combination of both. How does it work? Solar power plant. First, solar panel will receive sunlight and convert it into direct electric current. Second, the inverter convert electricity so that when it is used for equipment with an alternating current source, it can work. If using a DC source, there is no need for an inverter. The third is connecting the electrical power that has been generated by the solar panel so that it flows to the electrical panel component or switchboard. Fourth, the flow of electric current to electric equipment. 5. The last one is the electricity export and import meter for measurement and checking. One of the components that affect rainwater is piezoelectricity. Piezoelectricity is an ability posed by some crystal that can produce an electric current when subjected to pressure treatment. The piezoelectric effect can be used to convert mechanical energy into electrical energy. Therefore, piezoelectric materials are often used as a converter between mechanical energy into electrical energy. When there is a contact in the form of pressure or vibration, the piezoelectric will release an electric charge. The charge in the electric charge will cause a current pulse. The static converter circuit serves to store this current pulse into a storage unit such as a battery. Piezoelectric installation must be arranged in series, and when they are attached, there will be a voltage on the piezoelectric. The other component is using graphene. I found this component after watching the video on YouTube. and the video is there. Scientists in China produce solar panels with an additional source of rainwater. Solar panels with lots of photolytic sources. Electrons liberate the atom in the panel and this action generates electricity. One of the problems solar cell cannot produce energy when it rains. By adding graphene, Chinese scientists arrange graphene like a honeycomb to make the solar cell color sensitive to the color of the plastic layer of iridium oxide and tin included underneath. Graphene has the property of allowing electrons to move freely throughout the layer. Rainwater contains positively charged ions such as ammonium, calcium, and sodium. When water binds to the surface of the panel, the double layer is positively charged and the negative charge ends up producing voltage and current. Researchers from Ocean University of China claim that graphene-based solar cell can draw energy from raindrops falling onto the panels by soaking up a small amount of salt in the liquid. The graphene layers that make up the solar panels must be able to determine the positively charged ions in rainwater. This also includes sodium, calcium, and ammonium, as positively charged ions attached to a super thin layer of graphene. With the electrons already there, the potential energy and electricity trapped between the two thin sheets is what regulates the electric current. With these two components, we can find out the function of each of these components. Thus, I hope you can judge according to your respective perspective. In my opinion, the best component for using a solar power plant and rainwater is to use a piezoelectric component because with rainwater on the solar panel and coated with a piezoelectric component, the vibration will be more pronounced, especially with high intensity. And because the graphene component is difficult and expensive and has one particular problem, namely the relatively low concentration of ions in rainwater, which makes it difficult for technology to produce energy and electricity. Piezoelectric components to be the best in my opinion in the manufacture of solar power and rainwater. That's all from me for the presentation of opinions and presentation about combining sunlight and rainwater in generating electricity with renewable energy. Thank you for your attention. I'm Zidan Ulal Pap. Said goodbye. See you later.